Introduction to Linear and Nonlinear Data Structures. Data structures are essential components in computer science that enable the efficient organization and manipulation of data. They can be broadly classified into two categories: linear data structures and nonlinear data structures. 1. Linear data structures. Definition: linear data structures organize data elements sequentially, where each element is connected to its previous and next element, forming a linear order. Examples: some common linear data structures include arrays, linked lists, stacks, and queues. Characteristics: elements are stored one after another in memory, with a specific order. Access to elements is typically sequential, starting from the first element and moving towards the last. Insertion and deletion operations are performed at specific positions within the structure. Use cases: linear data structures are suitable for scenarios where data needs to be accessed or processed in a sequential manner. For example, arrays are efficient for random access and are commonly used for searching and sorting algorithms. Linked lists are useful when dynamic memory allocation and flexibility are required. 2. Nonlinear data structures. Definition: nonlinear data structures organize data elements in a hierarchical or non-sequential manner, where elements may have multiple connections or relationships with other elements. Examples: common nonlinear data structures include trees, graphs, and heaps. Characteristics: elements are connected in various ways, allowing for complex relationships. Access to elements can be non-sequential, depending on the specific structure. Insertion and deletion operations can affect multiple elements within the structure. Use cases: nonlinear data structures are beneficial when dealing with complex relationships between data elements. Trees are used to represent hierarchical structures such as file systems or organization hierarchies. Graphs are suitable for representing networks, social relationships, or dependency graphs. Heaps are used for efficient priority-based operations, such as finding the maximum or minimum element quickly. Understanding the differences between linear and nonlinear data structures is crucial for selecting the appropriate data structure for a given problem. Linear data structures excel in scenarios where data needs to be processed sequentially, while nonlinear data structures are ideal for representing complex relationships and dependencies among data elements. By choosing the right data structure, programmers can optimize the efficiency and performance of their algorithms and applications.